Let's get right into this explainer because today we're looking at something that honestly completely upended everything I thought I knew about maritime engineering. We are walking through a 94-hour operational simulation for a totally revolutionary high-tech disaster relief system. We're talking about bio-manufactured emergency fleets that literally grow their own hulls, generate off-grid infrastructure from scratch, and deploy autonomous drones straight to devastated coastlines. It is wild.
Okay, let's dive into this. Picture a massive coastal storm has just hit. Now, traditional steel relief ships have a glaring vulnerability. They need deep water ports to dock. But what happens when those ports are totally wiped out or clogged with debris? I mean, they're essentially useless, right? Enter the biomanufactured fleet. These new vessels have a super shallow draft, they feature a self-repairing organic hull grown from mycelium, and they rely on autonomous drones instead of deep-water piers to actually deliver the aid. It's a complete structural reimagining of how we do emergency response.
So, here is our tactical mission briefing for today. 1. Designing the emergency fleet. 2. Silent transit and energy. 3. Arrival and drone reconnaissance. 4. Tactical insertion and logistics. 5. The biofoundry apothecary. And 6. Achieving system equilibrium.
Part 1. Designing the emergency fleet, the bio-grown neo-pioneer vessel.
Let's look at the radical organic architecture that makes this whole thing possible. The foundation of this ship is a 380-foot hull that isn't forged from steel. It's actually grown. It uses structural arbor sculpture framing, which is essentially guiding living botanicals into specific shapes, and that's integrated with a super dense fungal mycelium biopolymer matrix. The result? A highly durable, incredibly lightweight vessel weighing in at just 4,200 tons. And because it's so light, it's got that shallow draft we talked about, letting it bypass destroyed ports and slip right through shallow debris-filled water. Oh, and because the hull is organic, it's inherently self-repairing. Yeah, it heals itself, which is obviously a massive advantage in post-storm wreckage.
Part 2. Silent Transit and Energy. The 1,300 nautical miles sprint.
Let's shift our timeline to day -3 and see how this thing actually moves. You can forget heavy, loud mechanical diesel engines. This fleet uses solid-state magnetohydrodynamic, or MHD, propulsion. It's all based on the Lorentz force equation. Basically, by using magnetic fields and electric currents, the ship's submerged ducts literally drive seawater backward. There are 0 moving parts, no propellers, no cavitation, no massive engine rooms breaking down. It's just a completely silent, frictionless glide across the ocean.
Now, what's really interesting about this is the energy budget driving those magnets. The ship packs a 420-ton aluminum air battery stack, delivering a massive 630 megawatt-hours of energy. The 1,300 nautical mile ocean transit takes the biggest slice, about 489 megawatt-hours, but look at the tactical insertion and equilibrium phases. They barely make a dent. Once the ship anchors, the MHD propulsion goes offline and it switches to a hyper-efficient microgrid. That leaves over 125 megawatt-hours in reserve. To put that in perspective, that is enough power to sustain relief operations on site for 102 days without needing a single recharge.
And when it's out there on the water, it is fast. Standard cruising speed is a swift 28 knots. But say the bridge detects hazardous weather or needs to make a sudden evasion, they can tap into these onboard supercapacitor pulse buffers. That delivers this instantaneous high-amp discharge that pushes the vessel to a maximum sprint speed of 42 knots. For a ship displacing over 4,000 tons, that is absolutely flying.
Part 3. Arrival and drone reconnaissance. Hour 0 offshore. So the ship has crossed the ocean and is arriving at the disaster zone. And during the approach, this incredibly clever logistics strategy unfolds. The ship has dual 40-foot aerostatic towers utilizing wind turbines and radiative cooling arrays to literally pull fresh water straight out of the atmosphere. But here's the genius part. They leave port with empty water tanks. That way they maximize the amount of dry goods and infrastructure they can carry, and they only activate these atmospheric harvesters a few days out. The tanks fill up just in time for arrival. It's the ultimate packing hack. You bring your own water towers, but you make the atmosphere fill them up on the commute. Part 4. Tactical insertion and logistics. The drone waves. All right, now we get to the actual deployment onto the devastated shoreline. Because there's no massive engine room to maintain, this 380-foot ship operates with a shockingly lean crew, just 36 to 42 people. They anchor 5 kilometers offshore to safely bypass all the toxic floodwaters, and then they kick off this super precise 3-wave drone deployment from a top-deck automated carousel.
Wave 1 sends in fast scout VTOLs to drop a communication mesh canopy over the whole site. Wave 2 brings in the heavy crew lift eVTOLs, flying human technicians right over the flooded, destroyed roads. And finally, Wave 3 starts a continuous loop of cargo VTOLs, landing crated supplies right into the hands of those technicians. It's like a perfectly choreographed aerial ballet.
And all those vital supplies, they're unloaded from a low-drag barge being towed right behind the ship. This barge is basically a disaster relief kit on steroids. Everything you need to instantly stand up a functioning daughter node ground grid. We're talking 20 crated water-empowered towers, 10 mesh communication masts, and 10 rechargeable electric cycles for mobility. But the coolest part has to be the dry Moringa seed powder. While the big infrastructure is being built, technicians use that Moringa powder to rapidly purify and flocculate the contaminated local water. It gives survivors immediate, safe drinking water on day 1.
Part 5. The Biofoundry Apothecary. Micropropagation in the disaster zone.
Now you might be wondering, and this is a really critical question, how do you guarantee identical, highly potent medicine in a completely contaminated zone? Think about it. You absolutely cannot rely on local agriculture or foraging wild plants after a massive storm. They're going to be subject to natural variation or, worse, covered in toxic floodwater. When it comes to medicine, you need total clinical reliability.
So the crucial point is this. The ship doesn't farm plants. It clones them. Tucked away on board is a 480-square-foot automated lab where bioprocess engineers take a starter kit of medicinal plant tissues. Using tissue culture cloning, also known as micropropagation, they can multiply biomass exponentially in liquid bioreactors in just a matter of hours. This guarantees that every single batch has the exact same genetic profile and predictable chemical potency. It completely bypasses all the risks of agriculture.
And their botanical manifest is perfectly tailored for disaster triage. They clone yarrow for trauma care because it's a hemostatic that quickly stops bleeding. They synthesize the toothache plant for pain management using its fast-acting local anesthetic, spilenthol. Sweet wormwood provides artemisinin to fight off fevers and vector-borne infections, which we know always spike after floods. And Moringa pulls double duty for extreme nutrition and that water purification we talked about earlier. The lab turns these into shelf-stable forms, loads them onto the cargo drones, and flies them directly to the people who need them.
Part 6. Achieving System Equilibrium. The 48-hour mark.
Let's map this timeline out and see how this all builds from an intense emergency sprint into a sustainable, long-term operation. On day -3, the ship is silently sprinting across the ocean, pulling water from the sky. At hour 0, it drops anchor safely offshore and unleashes the drone scouts. By hour 6, human technicians have unloaded the barge and are actively building out the ground grid. And by hour 48, boom, system equilibrium. In just 2 days, a devastated coastline goes from 0 to having a fully functioning, off-grid power and water node, with an onboard apothecary flying in custom-synthesized medicine on demand. Looking at how beautifully biology, magnetic physics, and drone engineering intertwine here, it's just amazing. The founder of the Neo-Pioneer movement described it perfectly. They said, "This is systems poetry at its finest. No corporate funding needed, no special interest, just necessity's mother making it happen. Can you feel it? Divine momentum?" Which leaves us with a pretty massive question to think about. As coastal climate disasters continue to accelerate and completely overwhelm our traditional infrastructure, is it time we replace our fragile reliance on heavy steel and combustion engines with the divine momentum of self-repairing mycelium and systems poetry? It is a profound shift in how we approach human survival. Thank you so much for joining me for this explainer. I hope this incredible system leaves you as fascinated and as eager to learn more as I am.